whenever you see an inequality that's like a sandwich, like right here, that's going to be considered an and, okay? So with and, it has to comply with both things. So let's look at this, and we're going to write the two equations. I always put the letter on the left for these. Remember we talked about this? But you need to make sure you write it right, because that big mouth of the greater than is facing the 2v minus 4, so you need to flip it when you flip that. And then you have 2v minus 4 is less than 16. The second part, the v's on the left. So you're drawing this here and then this here. Everybody understand what I did? The two problems? Then you solve those following the rules that we learned on Friday. So we're going to add 4 to both sides. We have 2v is greater than 12 when you add 4 to 8. And then v is greater than 6. And here we have 2v is less than 20 and v is less than 10. Okay? So when we draw our number line, we're going to put a 6 and a 10. And are these going to be donuts or dots?
Donuts.
And since it's an and, it needs to be everywhere that x is bigger than 6 and less than 10. I want to show you something. X is bigger, v is bigger than 6 would really be from here all the way to infinity and beyond, right?
Right.
And v is less than 10 would be from here all the way to negative infinity and beyond. But because it has to comply with both, the overlap is the only solution, because it has to be where both of those things happened. So the graph will look like this right here. It'll only go from 6 to 10. So when it's an and, it's where it overlaps. You only graph the part where it overlaps. So this would no longer be valid, and only the red graph would be valid. Now, if we're doing interval notation, it would be soft shell from 6 to 10 soft shell, because they were both donuts. Does everybody understand that? Remember when I said if you have green or blue on, you got to move forward, and only Grant was able to move forward because he had both? If it's an or, if you have one or the other, you get to move forward. So a lot more people came to the table, right? So when you think of and, you're only going to graph the overlap. When you think of or, you're going to graph the whole picture. Anything that got on the picture gets to stay on the picture. Okay?
Okay.
What happens in the picture stays in the picture. All right? So now we're going to add 7 to both sides. We have m is greater than or equal to 4. And here we're going to take away the 1. So it's negative 2m is greater than 10. And then divide by negative 2, what happens?
Negative 5.
It does, but what happens?
Oh, it switches. Oh, switch the sign.
Don't forget to switch the sign. Changes to a negative 5. So when I do my graph, I put in my negative 5 is to the left of 4 because it's smaller than 4. And does the negative 5 have a donut or a dot?
Donut.
A donut. Does the 4 have a donut or a dot?
Dot.
Okay, so m is bigger than 4 goes this way. M is less than negative 4 goes this way. So go ahead and absorb that, and then we're going to go over the interval notation for this. Does anybody want to take a stab at how we would do the interval notation for this? We're going to start looking at the left side of the graph. What number is where it hits on the left side of the graph, where it ends up? Keep going. Negative infinity. And it goes to negative 5, right? And they're both soft shells because it's a dot on the negative 5, and infinity always has a soft shell. Got it? And now what happens on the right side? It goes from what?
4 to infinity.
4 to infinity. Hard shell, soft shell, what?
Hard
shell on the 4, soft shell there because it includes the 4. And all you're going to do here is put a little u in there. And that means the union of those two sets of numbers. Let's recap hard shell, soft shell. Negative, less than, and greater than are a donut and a soft shell. Less than and equal to and greater than or equal to is a dot and a hard shell.